I am here with Dr. Federico Pezzotta. Federico,
nice
good to see you. And we are in MCP's room here at the Piscine at the SAINTE-MARIE-AUX-MINES show, the 2023. And you viewers are about to get a special world premiere. We filmed a segment in Tucson earlier this year, and we just finished post-production of it, and we're going to release it to the world, but we're going to release it to you guys first. So Federico, maybe you just have a couple quick words that you want to tell the audience about what they're about to see, and then we'll roll the film.
Perfect. Thank you for this opportunity. When you work in a laboratory, trying to make the specimen as better as they can be, cleaning, making them perfect, trimming, and presenting in the best way, one problem which arises is how to preserve this beauty. And when you are dealing with quartz, tourmaline, this type of minerals, you don't have any problem unless you take some care about not damaging them, not leaving them be covered by dust or some other funny treatment. Sometimes in the past, people were spraying, was putting oil, doing things like this.
Yeah. The good old days.
Luckily this is not no more happening. But when you have very sensible minerals, such as I am thinking at some paracoquimbite, which were sold to the market in the past, were available in the market in the past, or even some sulfides. The problem is that even if you have a very good care of them, sometimes they are prone to have some type of alteration.
Right.
So
from the environment.
For the natural environment.
Right.
So at this point, the idea is to think at some special system to preserve extremely rare minerals or even common minerals, but which will probably not survive if they are not put in a specific environment.
Correct. Yeah.
And it is not only to put a piece inside something in which it will be preserved. It is also a problem of putting the specimen in something which is still nice and that you can display. Because why you have to spend a lot of money for a nice piece when your nice piece must stay in a box or in some strange container to be preserved? You would like to see your piece in your showcase together with the other.
Right.
So the idea is to develop a system in which the piece would be preserved, but it will also be nice in the showcase together with the other pieces of your nice collection.
So it's preservation, it's about also allowing it to be shown. Exactly. And as co-owner of MCP, which is the world's leading mineral reparation and repair service, and as the curator of the Milano Mineral Museum, I think you have a very unique perspective on this, and I think the solution is going to be as fascinating for all of you to watch as it was for me to film and to watch you do your work. So
wonderful. Yeah.
Why don't we go ahead and roll the film?
Thank you.
All right. Okay. Enjoy.
Bye.
Hello. My name is Federico Pezzotta. I have been the mineralogy curator of the Natural History Museum of Milan, and at present I am the president of the Mineralogical Collection Professionals, otherwise known as MCP. MCP is widely recognized as one of the world's most important mineral specimen preparation labs, and we are fortunate to be able to examine and work on many of the most important mineral specimens in the market, in private collections and in museum collections. Having a quite significant experience in mineral specimen curating, I know that one of the most significant problems is represented by the preservation of certain minerals which can be more or less unstable. For instance, certain sulfide minerals, such as some wonderful pyrite specimen from Elba, naturally deteriorate over time to a point that, if not properly protected, they can decompose and fall in fragments. The reason for this process is due to the specimen being exposed to reactive atmosphere rich in moisture and oxygen. I brought here some specimen. For example, this is a nice crystal, twin crystal, iron cross twin crystal of pyrite from Elba Island, which has been recently cleaned, and indeed you can see it is on hematite, and you can see how fresh and lustrous it is. Here I have another example of a pyrite crystal, again iron cross twin, again from Elba Island, in which in any case you can see that the color of the surface is not as fresh as in the other crystal. It is more yellowish, and there is some iridescent coating forming at the surface, which is exactly the incipient alteration of the piece in the normal atmosphere in which there is moisture and oxygen. I have also another example, which is a typical example of a mineral very difficult to preserve, and it is marcasite. This marcasite is actually the result of what was preserved after years and years of a nice discovery in Czech Republic, something like 8 years ago. I had the opportunity of buying a nice group of specimens, and this is the only one which really survived after all this time. So, I've often thought that if there was a way we could preserve these specimens against the exposure, while also maintaining an aesthetically pleasing way to display, then perhaps we could help museums around the world preserve any sensitive mineral. Last year, my friend and colleague, mineral dealer Christophe Gobin, visited me in Milan at the museum, where we had some nice time in which we were inspecting in the exhibit some sulfides, including some Elba pyrites. And we talked about this very topic. He was deeply interested and offered to support the realization of a first experimental version with a carolite. He proposed a carolite since he is the expert of carolite from the Congo. Carolite is indeed a mineral which is quite stable, but occasionally it tends to form a superficial patina, which reduces the natural shine of the crystals. And for such reason, we thought it would be a good experiment to use one of the major carolite specimens for this new technique. Christophe offered to contact his good friends Stephanie and Robert Snyder, the owners of Stonetrust out of Connecticut in USA, to see if they would be interested in participating in our experiment. Stephanie and Robert indeed immediately agreed and contacted Paradise Wood, where they had placed a wonderful carolite crystal, to see if they would lend their piece to us for the experiment. The people of Paradise Wood were equally as exciting to try this out, and they quickly agreed to the loan, and with this set, we moved this project into full production. For a perfect preservation of a carolite crystal, we knew that we needed to create a closed environment that would be devoid of both moisture and oxygen. MCP research and engineering team went to work, and this video you are about to see is the result of that work. One thing I want to mention before you watch the video is our choice of gases that we used. We knew that we needed to replace the oxygen in the environment with an inert gas that would be immune to any chemical reaction with other chemical substances. This means that we had to use one of the noble gas, and we finally settled on argon. So, with that said, I would like to present you with this video of our experiment, and I invite you to share your thoughts and reaction in the comment section of this video. Thank you. We have the carolite specimen, which has been fixed on a carved base. So the piece now has been fixed on the carved base, with a system in which we can always remove. If in the future we would like to remove, we will be able to remove in a safe way. But now it is stuck
in the carved base. The base is round like the glass dome, which is here. This is the base below the carved plexi base, which is the technical part of the work, which there is this magnetic part, the center covering. This is the place in which the molecular filter is hosted. We will put here when we will be inside the glove bag. These are the channels connecting this molecular filter to the atmosphere of the glass dome. And this is necessary to keep the humidity zero inside the glass dome, and so to have a perfect control of the atmosphere. We have silicon, butyric silicon, with which we will fill this area, on which we will put the glass dome. And this is the glove bag. There is here below the bottle of the argon, which will be connected to this plug here. And we have the vacuum machine, which will be connected here. So we will open the glove box, glove bag. We will put inside all the parts. We will use the vacuum to remove all the air, and we will take out the vacuum. There is a valve here guaranteeing that no air will enter at this point, and we will put a pressure of 1 atmosphere of argon here. Then we will close again the argon, and we will suck out all the argon with the vacuum, and this is like to wash the environment from the air. Then we will detach again the vacuum, we will plug again the argon, and we will, when the glove bag will be full of argon again, at this point I will be able to put together the parts, close the glass dome, and at this point the experiment is done.
beautiful. Wow. That is wonderful.
Hello, Rob.
Hey, thank you for coming to our room today. Much
you.
appreciate this.
Thank
and we
you.
appreciate
Thank
you
you.
delivering this beautiful Carolite that's owned by Paradise Woods. Thank you.
Wonderful piece, and this needed some way to ensure its preservation for the future, even if Carolite is a quite stable mineral.
So tell us about what you're doing here. This is a sulfide, and you're trying to keep it from decaying or having it. What is the word? Decay, I guess it is. So tell me what you did and how you did this.
Yeah. So we studied a way to preserve the specimen in a controlled atmosphere in which there is no humidity, and the humidity is the origin of the alteration of the potential alteration of this type of minerals. So we studied the possibility of creating a basement like this, in which there is a chamber inside the basement.
All right.
And this is a magnetic cover of the basement and of the small plant which is inside. And there is the glass dome, and which is fixed in the base and sealed. And obviously the carved base, in plexi base, with the print of the base of the Carolite specimen was put inside with the specimen, and everything was closed under pure argon atmosphere. So we are confident that this atmosphere is sealed inside.
Yeah.
We have the molecular filter below, which is
a molecular filter underneath the specimen?
underneath. The chamber underneath is communicating with the chamber upward of the glass dome. So it will be efficient in removing any residual humidity which could be present inside the dome.
And so your goal long term is to help stabilize and protect specimens like this
Yeah,
long term.
exactly. Not only protecting long term, but also to produce an object which is nice to see.
Nice to look at. It's beautiful.
Yeah, personally I like a lot.
Yeah.
So I was very happy about
yes.
the final result.
And it's pure science. You're creating something that's never been created here before.
Actually, in the older collections of the museums, we know that people already made some domes, including some specimen inside.
Okay, yeah.
And I have experience of several museum collections in which these domes or cubes, glass cubes, which are covering and sealed on the bases with the specimen inside, are efficiently working. What is interesting here is that we have a variety of specimens in the market and in the collections, in general in the collections. Some of these minerals are not perfectly stable.
Yes.
The scientific study actually concerned the stability diagrams of the different minerals with the temperature and the humidity.
Yes.
Of the atmosphere, at one atmosphere, because we are studying at room conditions, obviously not deep in the earth or things like this, like petrologists are doing. So at 1 atmosphere pressure, this diagram stability with temperature and humidity are very important for the different minerals. A few nice minerals are sensible to this type of variations, and the goal is to create domes like this with inside of each dome the right atmosphere to preserve this specific mineral. There are minerals like sulfides which don't like at all humidity, but there are other minerals I was mentioning before, paracocumbite, which I hope to create something useful for it, in which you need a specific humidity. And there are other minerals which have other type of problems. So we are studying the different possibilities. And obviously, we move little by little gaining as much as experience we can on each different type of mineral, with the goal in the future to have a line of these different objects for the different minerals.
So it's, to a layman like myself, it sounds like you're trying to save the world's best sulfide crystals, one argon glass-filled dome at a time.
Yeah,
right?
I tell you something interesting. I was discussing with other colleagues about this solution, and there are localities which were in the past giving fantastic crystals, which are quite no more existent in the collection.
They crumble. Yeah.
I am referring, for example, to some historic Elba Island pyrites.
Yes.
And there is a project, for example, when I show that there is the possibility of creating this kind of solution for preserving the specimen, there is a project now in which they are asking maybe you can go back to the mines, ask a special permission to feed museums again of these specific crystals, saved in this way, close again the works, and have a representative of these minerals in the collection of the best museum. So this is just an example how this project could help collection and display.
Thank you so much for doing this. Again, I want to thank Paradise Woods for providing the specimen for Federico to do this. It's fantastic. The science that's involved here is wonderful, and we hope this becomes a standard process for all future minerals like this.
I would like also to thank in this project the several people which were supporting, not only the scientists, but also I can mention Christophe Gobin.
Oh, Christophe,
Christophe, who really pushed me in this direction, and also he was stalking me.
Stalking?
Yes.
Well, he's been known to do that.
Yes, exactly. And the other people close to me, which helped so much. And I have a special guy in my company, which name is Mino, who was extremely happy to work in this project, and who at the end is the physical worker which created the different pieces and helped in having this final solution.
It's beautiful.
Yeah.
Thank you so much.
Thank you. Thank you.